Hey guys, so in our last video, we discussed how to factor polynomials by grouping. And to start today, if you look at the top of your screen, we've got two polynomials here, which I will tell you now, we can factor by grouping. And just to refresh our memories, and because it's going to be really helpful for this lesson, why don't you take a moment to pause the video, factor these two polynomials by grouping, and when you're done, play the video, and you can check your work, and I'll walk you through them. Okay, so for this first polynomial, let's go ahead and group our first two terms. So we get a 4h squared minus 8h. And let's go ahead and group our second two terms. So I have a 3h minus 6. All right, now looking at this first grouping, we're looking for common factors, and I think I see a common factor of 4h. So we can write that as 4h times the quantity of h minus 2. In our second grouping, I see a common factor of 3, so we can write this as 3 times the quantity of h minus 2. And so we see that since we've got h minus 2 in this set of parentheses and h minus 2 in this set of parentheses, we can rewrite this line as the product of 4h plus 3 times the quantity h minus 2. Awesome. Groovy. Let's do one more real quickly. Here, once again, we'll group our first two terms together, 5y squared minus 15y. We will group our second two terms together, 6y minus 18. And let's do it again. So looking at our first grouping, I think I see a common factor of 5y. So we can write that as 5y times the quantity of y minus 3. In our second grouping, I see a common factor of 6. So we can write that as 6 times the quantity of y minus 3. Awesome. Hopefully you see where this is going. So I think we can go ahead and write this line here. Last step, we can write that as the product of 5y plus 6 times the quantity of y minus 3. Awesome. Now, this was all good, and we were able to factor both of these by grouping. But I'm noticing that if I look at our original polynomial, I see some like terms here. I see a negative 8h and a 3h, and perhaps our first impulse was, well, why don't we collect our like terms? And if we did, this polynomial would have been 4h squared minus 5h minus 6. And the same thing for our second polynomial. I see a negative 15y and a positive 6y. We could have grouped, or rather collected those like terms, and we could have rewritten that polynomial as 5y squared minus 9y minus 18. And the question is, well, I actually don't think that right now we have the skills to factor this polynomial or this polynomial, right? It's a trinomial. The leading coefficient is not 1, and neither of these are perfect square trinomials. But, well, we can factor them because if we knew to split up this negative 5h into negative 8h plus 3h, and of course these two combine to give negative 5h, if we knew to take this polynomial and split the middle term as such, well, then it factors nicely by grouping. Same thing with this polynomial. If we just took this first polynomial and looked at it, we probably wouldn't know what to do. But if we knew to split up negative 9y as negative 15y plus 6y, well, then we would have a polynomial that factors by grouping. And that is exactly what this lesson is all about. It's about taking trinomials whose leading coefficients are not 1 and who are not perfect square trinomials and figuring out how to split up this middle term or this middle term so that you end up with something that we can factor by grouping. That's what it's all about. And there's really just one skill we need to learn, and once we have that, we're good to go. So my claim is there is a way to split up this negative 7m in this polynomial so we get something we can factor by grouping. Now, how should we do it? Well, there are a million ways to split up negative 7m. All we're doing is going to write two terms here that add up to negative 7m. So which way to split it up is going to be the best? Well, here's my claim. We're going to want to split this up into two terms that I say interact well with 6m squared and with negative 10. And this is what our strategy is going to be. First things first, let's actually multiply this coefficient on our leading term and the constant. So 6 times negative 10 is negative 60. And that negative 60 is going to be a very significant number for our purposes right now. So much so that I'm going to write it down here. Okay, now what we need to do is we need to find two numbers that multiply to give negative 60. So two factors of negative 60 who add to give this negative 7. So I'm going to write down the factors of 60 real quick. I think we've got 1 times 60. I think we've got 2 times 30. 3 times 20. We'll learn a lot. 4 times 15. 5 times 12. and 6 times 10. Of course, if these are going to multiply to give negative 60, in each of these pairs, one will be positive and one will be negative. So the question is there any way to take a pair of these numbers, one of which is negative and one of which is positive, and have them add to give negative 7? Why don't you take a look and see if you can find it? Well, my claim is if we did 5 times negative 12, 5 times negative 12 is negative 60, and 5 plus negative 12 is negative 7. So if we split up this negative 7m into a 5m minus 12m, or negative 12m plus 5m, we will then have a polynomial that we can factor by grouping. So if we split this up into 6m squared minus 12m plus 5m minus 10, well, look, we really didn't change what this polynomial is. We just changed what it looked like, right? Negative 12m plus 5m, if we collected those like terms, that's what we'd end up with right there. Well, now I claim that we can factor this guy by grouping, right? If we collect those first two terms, so we've got 6m squared minus 12m, we'll group those second two terms, 5m minus 10. Now let's see, in our first grouping, I think we've got a common factor of 6m, so 6m times the quantity of m minus 2. In our second grouping, we've got a 5 as our common factor, 5 times the quantity of m minus 2, awesome. And so I think the full factorization is going to be 6m plus 5 times the quantity of m minus 2. And if you were to go ahead and multiply these two polynomials together, this is exactly the product you'd get. So it's all about figuring out how to split up that middle term. And all you do is you find the product of the leading coefficient and that constant, in this case negative 60, find two numbers that multiply to give negative 60, who will add to give this coefficient. Note to self, if you had done 6m squared plus 5m minus 12m minus 10, you get the exact same factorization. And I leave it to you to confirm that. Let's do a couple more examples. So here, all right, we've got one of these trinomials. So we're going to want to split up 15b in such a way that hopefully we can factor this by grouping. Because right now we don't have the skills to factor this. The coefficient, the leading coefficient is not 1, and I'll tell you this is not a perfect square trinomial, even though this is a perfect square and this is a perfect square. So what do? We're going to multiply our leading coefficient by this constant. 4 times 9 is 36. And what we need to do is find two multiples of 36 who will add up to 15. So I'm thinking, what are the multiples of 36? 1 times 36, 2 times 18, 3 times 12, 4 times 9. All right. Of course, these could be either both positive or both negative. Is there a pair of factors of 36 who will add up to 15? Yes, positive 3 and positive 12. So we can rewrite this polynomial now as 4b squared plus 3b plus 12b plus 9. And note to self, the order does not matter. You could have done 12b and 3b. It factored just the same way. And hopefully now we're on autopilot. All we need to do is factor by grouping. So let's group that first pair together, 4b squared plus 3b. Let's group that second two terms together, 12b plus 9. 12b plus 9. In that first grouping, I think I see a common factor of just b. Just b in this case. So b times the quantity of 4b plus 3. In the second grouping, I'm seeing a common factor of 3. I think we can write that as 3 times the quantity of 4b plus 3. Awesome. Meaning that the final factorization in this case would be b plus 3 times the quantity of 4b plus 3. And if you were to multiply these two out, this is exactly the polynomial you'd get. So I hope we're getting the hang of it. Let's do some more examples just to practice. All right, guys, just 4 more examples to work through. And I urge you, if you feel like you've got a hang of this, feel free to pause the video and try to factor these on your own using this new splitting method, and then play the video and see how it went. Or if you need some help and need to be walked through them, that's fine too. You can just follow along. Okay, so in this first example, we've got a trinomial. The leading coefficient is not 1, okay? And this is not a perfect square trinomial. So none of our previous strategies are going to work. We've got to use this splitting method. Okay, so what we're going to do is we're going to have to somehow split up this negative 19a in such a way that we could then factor by grouping. So in this case, we're going to find the product of 4 and negative 5. Those guys multiply to give negative 20. Okay, and now we're thinking, what are the factors of negative 20? We've got 1 and 20, we've got 2 and 10, and we've got 4 and 5. Of course, 1 would be positive and 1 would be negative in each of those pairs. Now, are there any numbers then that multiply to give negative 20 and add together to give negative 19? Boom, positive 1 and negative 20. So we're going to split up this negative 19a into positive 1a and negative 20a. And the order in which we write it is not going to matter. So in this case, I'm going to write this as 4a squared minus 20a plus 1a. I'm not going to actually write the 1. I'm just going to write plus a minus 5. All right, now, supposedly, we should be able to factor this by grouping. And hopefully, again, we're on autopilot at this point. So let's group those two first terms together. So we've got a 4a squared minus 20a. Let's group those second two terms together, a minus 5. Awesome. Looking at the first grouping, I think I see a common factor of 4a. So we can write that as 4a times the quantity of a minus 5. And in our second grouping, I think our greatest common factor is just 1 times a minus 5. And so the final factorization should be 4a plus 1 times the quantity of a minus 5. Awesome. And the best way to check your work when you're done factoring using this splitting method is multiply these two together. And hopefully you'll end up with this original polynomial as your product. Great way to check your work. All right, let's proceed. Let's do some more. So we've got one of these trinomials again. Let's go ahead and split up 20x so that we can hopefully factor by grouping. So 4 times 25 is 100. So we're going to write 100 off in the corner there. And now we got to find the factors of 100. Do you need to write them all out every time? Absolutely not. I sometimes do so because it just helps me keep track of everything. So we got 1 times 100. Let's see, 2 times 50. 4 times 25. 5 times 20. 6, 7, 8, 9, 10 times 10. All right. So now we got to see, are there any factors of 100, numbers that multiply to give 100, that add to give 20? Yeah, I think positive 10 and positive 10. Let's do it. So let's split this 20x into a plus 10x and plus another 10x. So we'll rewrite this guy as 4x squared plus 10x plus another 10x plus 25. Okay, so let's see if this guy actually factors by grouping now. We'll group those first two terms together, 4x squared plus 10x. We will group those second two terms together, 10x plus 25. Looking at that first grouping, I think I see a common factor of 2x. So we can write that as 2x times the quantity of 2x plus 5. And in that second grouping, I see a common factor of 5. So we can write that as 5 times the quantity of 2x plus 5. Meaning our final factorization in this case is going to be, well, very interesting. Excuse me, I forgot to actually write that 5 there. Pardon me. Much better. Which means our final factorization in this case is actually going to be, 2x plus 5 times 2x plus 5. Or I'm even going to write that as 2x plus 5 quantity squared. Which means, our original polynomial here must be a perfect square trinomial. We forgot to look for that. Let's see. 4x squared, that is definitely a perfect square. That is 2x quantity squared. 25, definitely a perfect square. That is 5 squared up. This guy was a perfect square trinomial. We didn't have to use the splitting method. But you know what? It worked anyway. So good to know that even if you forget to look for a perfect square trinomial, this splitting method can totally work. All right, making our way onward. Let's take a look at it. It's a trinomial. Leading coefficient is not 1. That strategy is out the window. Is this one a perfect square trinomial? Nope. Boom. That strategy is out the window. Okay, so we're going to need to use this splitting method in this case. So 3 times 4 is 12. So we're going to look for factors of 12 that add to negative 9. So we've got 1 times 12. Of course, they could be both positive or both negative. 2 times 6, both positive or both negative. 3 times 4. Both positive and both negative. So, are there any factors of 12, two numbers that multiply to give 12, that add to give negative 9? Well, let's take a look. That's not going to work. That's not going to work. We can get 8. And that's not going to work either. So you know what? Since there are no numbers that multiply to give 12 and also add to give negative 9, there's actually no way that we could split up this middle term in any way that we could ever be able to then factor by grouping. So right now, with our skill set, we are totally unable to factor this polynomial. We're just going to have to leave it as is. Womp womp. All right, one more example. Here we go, guys. Let's finish up strong. So we got a trinomial. The leading coefficient is not 1. Is it a perfect square trinomial? Nope. All right. Looks like we're going to have to use this splitting method. So, all right, here we go. 2 times negative 30 is negative 60. So negative 60 is going to be our magic number in this case. All right, so we're going to go ahead and list these factors of 60 to help us figure out how we might be able to split up 4a. Maybe you can do this in your head, but I don't know all the factors of 60 off the top of my head, so I kind of have to write them down. So 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. All right, so are there any, and of course one would be positive and one would be negative to get negative 60. Are there any ways to use these numbers, these factors of negative 60, and add them together to get 4? Actually, yes. If we did negative 6 times positive 10, those multiply to give negative 60, and negative 6 plus 10, they add to give us 4, so we've got our way to split this up. So let's split up this 4a into 10a minus 6a. You could, of course, do it the other way around. It would work out just fine as well. So 2a squared plus 10a minus 6a minus 30. All right, let's do it. Let's group these first two together. So we've got 2a squared plus 10a. Let's group these second two together. We've got negative 6a minus 30. And all right, common factor from this first grouping, I think I see 2a as our common factor. So 2a times the quantity of a plus 5. And from the second grouping, let's factor out a negative 6. So negative 6 times the quantity of a plus 5, looking awesome. And so this should factor as 2a minus 6 times the quantity of a plus 5. Booyah! But check it out. Wait a second. We're actually not done. Why? Look at this first binomial right here. 2a minus 6. We can factor out a 2 from that. Right? 2 goes into 2a and 2 goes into negative 6. We can write that as 2 times the quantity of a minus 3, then all that times a plus 5. And what does that mean? It means that we could have factored out a 2 originally from our original polynomial. Oh man. So if we had done that, we could have rewritten this original polynomial as 2 times the quantity of a squared plus 2a minus 15, and then this right here, this is a trinomial whose leading coefficient is 1, and we do know how to factor that. And that would factor as, hopefully you already know, 2 times the quantity of a minus 3 times a plus 5. And so we see that, once again, here we forgot to look for common factors, but as long as we don't forget to look for them later, we will still end up okay. So 2 different ways to arrive at the same factorization. So I hope you enjoyed, and I hope you found this helpful.